gas forming reactions. The first of 6 is when an acid and a metal react to form hydrogen gas and a salt. Let's add some zinc to some hydrochloric acid. We stopper it and we see bubbles of hydrogen gas coming out. We collect it by displacing the water downwards. And then when we test it, we explode it. It makes that characteristic popping sound. Let's look at that in slow motion again. Notice how the flame jumps into the test tube. And a larger amount. Let's watch that in slow motion again. That's real rocket fuel, a 2-to-1 mix of hydrogen to oxygen. So we've just seen the hydrochloric acid and zinc making the hydrogen gas, which bubbles off, and the salt zinc chloride. And then to test for the hydrogen, we exploded it, and it makes water. Number 2, acid and carbonates make carbon dioxide, water, and a salt. An acid plus a carbonate makes carbon dioxide, a salt, and water. There we have some clear lime water. Here we have some bicarbonate of soda. We add some acid to the bicarb and we get bubbles of gas. We pass it through clear lime water. It goes that milky color, which is confirmation that the gas is carbon dioxide. Let's try that again, but adding some universal indicator to see some color. Again, we add the bicarb to the acid, and we see it frothing over. And where the blue is, it's the bicarb, which is alkaline, and the pink is the acid. Hydrochloric acid plus sodium bicarb makes carbon dioxide, water, and sodium chloride. And then the clear lime water going milky, it's because of the calcium carbonate precipitate that is white, as calcium carbonate is insoluble, as we saw in the first videos. Number 3, an acid and a sulphide makes hydrogen sulphide, a rotten egg smelly gas. Hydrogen chloride plus zinc sulphide makes the smelly gas, hydrogen sulphide, plus zinc chloride salt. Yeah, it doesn't smell very good. It's not as if it really needs a test, but if you bubble the H2S through a soluble form of copper, like copper sulfate, you start seeing the black precipitate of copper sulphide. And here are the equations. Zinc sulfide plus hydrogen chloride makes the H2S plus zinc chloride. And if we want to test that the gas is hydrogen sulfide, we just bubble it through a soluble form of copper, in this case copper sulfate, and it forms the black copper sulfide precipitate. Number 4. Acid plus a sulphite salt reacts to form sulfur dioxide. We add the acid to the sulphite. Yep, it's a choking smell, and sulfur dioxide is acidic, and we see how it changes universal indicator from purple to pink. Hydrochloric acid plus sodium sulfite reacts to form sulfur dioxide plus water plus sodium chloride. Number 5, nitric acid plus copper forms nitrogen dioxide, a brown gas. We pour some concentrated nitric acid into this dropping funnel, which allows me to carefully add the nitric acid into the erlenmeyer flask where the copper is. and instantly we see this brown gas is formed. The brown gas is called nitrogen dioxide. Nitrogen dioxide is the smog we see over a city at the end of a day. It comes out of exhaust pipes. Let's pass it through water that has some universal indicator in it and see how it changes it from blue to red. This time it's the nitrate component of the acid that reacts with the copper to form the nitrogen dioxide brown gas. It also forms water and copper nitrate, which is the blue color at the bottom of the erlenmeyer flask as the copper dissolves. Heating potassium chlorate to produce oxygen. Here we have a mixture of potassium chlorate and manganese dioxide, and we heat it strongly on a Bunsen burner. The manganese dioxide acts as a catalyst and assists in the potassium chlorate decomposing. You see the glowing splinter continues to glow, but it's not enough oxygen to make it burst into flame. So we're repeating it now, collecting the gas in a test tube, and once the test tube is full, we test it with a glowing splinter, and this time there's enough oxygen for it to ignite, proving that the gas is in fact oxygen that was released when the potassium chlorate was heated, and the residue is potassium chloride. And all six listed together, producing hydrogen, carbon dioxide, hydrogen sulphide, sulfur dioxide, nitrogen dioxide, and oxygen.